It was done that way just to kind of keep things as simple as possible. So it's easier to think of the quick API and more as a generic thing, just like the TCP API is generic, right? It would be the exact same. So there are a couple of, let me know if I need to bump up my font size, but there's a couple of objects. There's the quick endpoint, the quick session, or quick socket, quick client session, server session, and then there's quick stream. Okay? Both quick client session and server session extend from the same base. Okay. Okay. So the way these lay out, a quick session is independent of the network socket, right? You can, once it's established, you can actually change your network switch from Wi-Fi to mobile or whatever, and it does not invalidate the quick session. You can migrate that session from the client from one connection to the next. And it's actually possible on the server side to listen to multiple local UDP ports on a single server, and receive packets from those multiple different ports and have it all relate back to the same session. Okay. So instead of the one-to-one type of relationship that we have right now with HTTP and TCP in general, we have these two classes, quick socket and quick endpoint. Quick endpoint represents a specific binding to a UDP port, a local UDP port, right? And it wraps what we, the existing UDP API. Okay, wraps it and completely hides it. Quick socket is an abstraction representing one or more quick endpoints. Quick socket is the thing that you get back when you call create quick socket. And you require from net. And then you would create either, it can be either client, a single quick socket connected to the client or a server. It doesn't matter. And it can be both at the same time. So if you just say a quick socket with the default parameters, okay, what you're getting back is this quick socket class, which has a single quick endpoint associated with it. Right now, the API is limited to just that single. Later on, we'll make it where you can add more, but theoretically, it's written, it's implemented to allow more than one.
What is an endpoint?
I'm sorry?
What is an endpoint?
Endpoint is basically a wrapping for an existing UDP wrap.
Oh, so the switching Wi-Fi, etc., happens on the layer below socket. Okay, I misunderstood that.
It can. It doesn't yet, but it can. The intent of this is to make it so that later on we can implement that support. If the network changes, it'll happen completely transparently.
Because then I lost you. What is the difference between a socket and a session?
The socket is the actual as an abstraction for the local UDP binding. The session is the actual stateful conversation happening between the client and server. Okay.
And so if we switched endpoints underneath the socket, we could, so the session wouldn't even care about that. Okay.
You'll see a slight hiccup in terms of performance as the session attempts to revalidate the network path. Quick has path validation built in. So when it receives a packet from an endpoint that it has not seen before, what it will do is do a quick packet exchange. Basically, it's a challenge response type of thing to ensure that the endpoint, the other end, is actually the endpoint it should be talking to. This is a way of preventing certain types of attacks that involve changing the UDP port once the conversation's already been started. Okay, that's a lot of detail that we don't need to go into right now if we're just talking about API level. The point is, quick socket is the abstraction for the UDP binding. Quick session is the actual conversation that's happening. And there's two different roles. There's the client side and the server side of that. For the most part, the APIs for both are identical. They are going, there's going to be some very minor variations between them. But for the sake of this conversation, we can pretty much just say, instead of quick client session and quick server session, we're just going to talk about quick sessions in general. Okay. So once a quick session or once a quick socket is created, you can either tell it to listen, basically act as a server, or you can tell it to connect, which is you're telling it to act as a client, right? And it can, like I said, it can do both at the same time. With listen, what's going to happen is it instructs that quick socket to start listening for incoming UDP packets to initiate a new session. When it receives those and validates those, there's a variety of details that go on under the covers. It will create the quick client, the quick server session, and trigger an event. That event is the on session event.
But before we go too far, can you talk about why you would have it listening and connecting at the same time? Like, is there a use case you see where that's really handy, or?
If we're talking about like a server, like a proxy type of environment, then you can have the single, you can create the single quick socket receive and then forward on to to another server. So proxy environments is one of the use cases.
It's really just a performance concern, because otherwise you would just open up a separate socket for the upstream.
Yeah. Okay. Here it was just there was no real reason why we had to limit it, right? It was just because it just works either way.
You don't see us at the higher level or the frameworks offering this as a feature to enable some end user behavior, right?
If you expose the quick socket to somebody, then they can do that themselves. The higher level API doesn't really need to expose that. Okay. All right. So quick socket, when the new session is created, new server session is created, we get this on session event. What's important to understand is that this session at this point has just been created. The TLS handshake, it hasn't even started yet. It will start as soon as this event is done being processed. Okay. So as soon as the object is created, you get this. So this session at this point cannot be used because it's not in a state where it can be used. It can be used to exchange information. What you do though is you start to attach your other event listeners to it. And the most important one is the session on stream. Okay. Now the session on stream is really the equivalent of the existing API. This is like the on request. All right. Once the TLS handshake has been established, once that is done, which by the way, you can know when that's done by using the session on secure event. Okay. So anytime after the on-secure event happens, you'll start getting on-stream events. And this is when the peer, in this case the client, initiates a new stream with the server. Streams can be unidirectional or bidirectional. Okay. If a client opens a bidirectional stream, both the server and client can write to it. If the client opens a unidirectional stream, only the client can write to it, and the server can only read from it. It cannot write back. The server can also create bidirectional and unidirectional streams. Okay, and with the same rules. If a server creates a bidirectional stream, then both the server and the client can write to it. If the server creates a unidirectional stream, only the server can write to it, and the client can only read. Okay.
So if I understand this correctly, this is the underpinnings of the push stream, right?
Yes. It's kind of a lower level idea of the push streams. The difference between push streams here is in just plain quick. We take the HP3 semantics out of it. With quick, the server can initiate those streams anytime it wants. Unlike an HP2 push, the server can only initiate a push in response to a client request. Okay. So it's possible, for instance, for the quick client to establish the connection and then do nothing else, and the server just starts opening streams.
Ah, very interesting. Okay, right. So does the I read some of the spec here, but I think maybe I missed this part of it. Does for the HTTP3 semantics, does that add a layer of requirement for it to be in response to a request, or is that similarly open-ended, like a, you know, if the
so HP3, if we're talking about purely HP3 semantics, the push semantics are the same as HP2. So the server is only supposed to open a stream back if there is a corresponding request. Okay, but there's nothing in the quick specification that says that that server can't go ahead and open a regular quick stream, a non-HP3 quick stream. And whether or not that is supported is up to the client. The client can reject that if it doesn't want it. Okay, so you can have, in theory, HP3 and regular quick and just kind of raw quick going over a single session if the client allows it. Okay. Now, that's not something I think we want to get into too much because there's all kinds of complexities and interop issues around that. I highly doubt most HTTP implementations, HP3 implementations are going to be set up to support that in any way. So I'm not optimizing for it. I'm not optimizing for it, and I'm not doing anything specific to allow for that. But in quick, it is possible. Okay. All right. So the session on stream is going to tell you when the peer initiated the stream. Anytime after the onsecure, actually you can do this before. So anytime in here, like say if the server wants to initiate a stream, it can come up here and say open stream, right? And there's some details in here whether it's unidirectional or not. The name is, I'm going to be changing the name, but say if it's tap open, it's unidirectional. Or if you just say await stream. Now to keep in mind, this is a promise returning API. I'm implementing the quick client API as around promises purely. So there are differences here. So connect will return a promise. OpenStream returns a promise. Most of the APIs will return promises. So you await the stream. Once that is open, then you just use the regular stream API to send the data. Okay.
Can a quick stream be half open?
Yes. Yep. When you close, say if we just did this, the stream and write and end, the stream is still readable. It's just no longer writable. All right, and it will stay open until either you call close, destroy, or the peer closes. The difference between close and destroy is immediate. It's immediately destructive. Whatever state the stream is in, it's just torn down immediately. Close is a graceful close. So what this tells you, it's the equivalent of calling end and reading all the data. Okay.
So if you call close, will that actually wait for all the data to be read?
It will wait for the stream to finish naturally, right? And what it does is it gives you a promise. So when you await close, you're basically awaiting the natural close of the stream, and then proceeding once it's closed.
So semantically, it's the same as calling stream end, stream resume, and then await finished stream,
Yes.
right?
Yep.
Okay.
Yep.
So stream destroy is returning a promise, or is a synchronous API?
It's synchronous. Okay. So all of the destructive functions, so all on all of the objects, calling destroy on all the objects is an immediate synchronous destructive action, and the object cannot be used after it's destroyed. Okay. So unlike existing APIs where destroy might schedule a next tick, or set immediate for cleanup or whatever else, the quick implementation has been written so that destruction is always immediate and synchronous. So, okay. All right. Now, these open streams, Quick does support the idea of zero round trip, which is basically initiating a stream while the TLS handshake is still pending. Because of some timing issues that we have with the way the streams API works, we can't actually do that yet, but the API is set up for it. So this open stream, it returns you a promise that will resolve when the session is in a state where it can open the stream, which is after the TLS handshake completes. Okay. But you should never depend on the exact timing of that, right? So you're awaiting the promise. Don't assume that it's synchronous or asynchronous. Okay. All right. So the stream object, for the most part, it's just a duplex. Okay. You read and write data from it. It has some specific properties on it that are quick specific. So you can get the stream ID. Every stream has a numeric identifier. That identifier will actually tell you, if you know the rules, the identifier will tell you who opened the stream, which peer, and whether it's unidirectional or bidirectional. But we don't want to make everybody do that work. So we have some utility properties bidirectional. Let me see if I can or unidirectional, right? So you have some properties, and then you have client initiated or server initiated. They're just utility getters that make it easier for you to know whether that thing is going to be readable, writable, who created it, that kind of thing.
Why would you need bidirectional, unidirectional? Isn't it enough to read stream readable, stream writable? Or is that a deeper discussion?
Possible. That's a different discussion. Yeah. It's yeah. It's going to depend on whether you need to know what type of underlying stream it is, independent of the readable writable state, and that's something that haven't quite determined yet. So it's there, but we'll see. All of this can change, right? So no part of the API is set in stone yet. Okay, but like I said, but for the most part, this is just a duplex. It's just a duplex with a graceful close option, right? Using the close. Okay. Now, if we called session close, again, this is promise returning. What that's going to do is, if there are no open streams, it will go ahead and destroy everything now. If there are open streams, it will stop the peer from being able to initiate new streams, right? And it will allow the existing streams to close naturally on their own. And then once all those close, it will then destroy the session and resolve the promise. Okay.
Would that ever throw anything?
It can throw, right? If there is, if if there's some other error that happens, if the session ends up getting destroyed with an error at any time while that promise is pending, the promise will be rejected with that error. Okay. Again, there's lots of details here that still need to be worked out to make sure it all works, but that's the general idea. Same thing with all the objects. All the objects have a close, except for quick endpoint, because that quick socket manages that. So you have quick socket, quick session, quick stream, all have graceful close options that return promises that will short circuit if the object is destroyed with an error.
Also, a stream thing, if you destroy the stream without it having been totally read, will it error then, or it just, you know, quietly?
Yeah.
Yeah.
It should error. Okay, and I don't think I quite have that working yet, but it should. Go ahead.
If we're writing, you know, long-lived services and we have long-lived clients, do we need to manage a pool of sessions with limits and all that sort of stuff, or is that sort of built in here? Like if we start hitting, you know, like this seems like it could be a leak, right? If you just had hundreds of really long-lived clients that just never let go of their end of the session.
So Quick has an idle timeout built into it, and it's configurable at when the session is created. So the peers, and each peer will set their own idle timeout. If there is no network activity, no activity on the session within that window, the session will automatically be destroyed. By default right now, I have that set to 10 seconds. So if there's no network activity on it, 10 seconds later, the session will get destroyed. Everything will get cleaned up. Now, Quick is purposefully designed to make it so that a session can be long living. So you can specify a super long idle timeout and just have it sitting there. Whether or not that's something you want, I mean, it's going to be completely up to you. But idle timeouts are built in, and that's on any of the streams. Now there's going to be kind of a keep alive method that you can call. It's called ping right now. Unlike the HP2 ping, there's no response to it. It's just a, hey, send something that keeps this thing alive. So if you set a timer, every 5 seconds or whatever, do a ping, what it's going to do is serialize some packets that are enough to keep it alive.
Is there, say you do want you have a scenario where it makes sense to have long-lived clients like that. Is there any handling for refusing those, or do you just do normal, refuse the?
You just do normal refuse.
Okay.
Now, in theory, what you should actually be able to do is basically sleep your sessions. So at some point in the future, we may actually get to a point where we create a session. There is a resume. We can use TLS resumption here. So once the TLS handshake is established, you can record some information. So the next time you want to create the connection to that server, you would just specify the session ticket and resume the TLS connection. So instead of it taking 3 hops, it takes 1 hop to resume everything. So super, super cheap to restart the TLS connection. So in the future, we might actually be able to have a thing where you take a session, an existing Quick session, and serialize its state, right, along with the session ticket. And then when you want to, and then you can sleep it, you can tear everything down, come back later, and basically have a virtual long-lived session simply by deserializing the state and resuming the connection. It's not something that I've started playing with yet. I've mapped out kind of how it would work, but it would essentially allow us to have long-lived connections without having to hold everything, all the memory, all the state in memory. Okay, that's an advanced topic down the road, quite a bit down the road. All right, so Not all quick protocols support headers. Quick is essentially just a bidirectional stream. It's just a duplex. At the quick level, there is actually no concept of headers. But we do, HP3 does introduce this. So what I've done is I've created an abstraction within the Quick API that if we know that the application supports headers, and we have implementation for it at the C++ level like we do with HP3, then there is an API for setting and getting headers off the stream. So what you can basically do, there are several of them. You can say like get initial header, on initial headers. The names might be a little bit different, but you have like trailing headers. And then I think informational. Okay. So if the application supports it, then we'll get these. Then you can get these header events. All right. Now this is extremely low level, and that what the headers get, you don't get a nice headers object right now. You get an array of header objects. Basically, an array of arrays where each member is a name and key pair, a name value pair. Okay, so we don't go through and convert it to an object, and the reason for that is just pure performance. Converting that into an object is since it's quite expensive. We may go back and go ahead and do that anyway in the future, but for right now, it's just an array of arrays. Okay. We do keep track of whether this is an initial header would be a request or response header, right? So it's the same event on client side or server side. On the client side, these are the response headers. On the server side, these are the request headers that you're getting. Informational would only actually happen on the client side. These are the 1xx status headers. And trailing headers are, of course, the trailers, right?
And so this level doesn't differentiate between like HTTP's meta headers. Yeah. Those come as initial headers.
Those will come here too. So you'll get the colon method, the colon status. You'll get all headers here. There's no differentiation between. Right, and there's no deduplication. So there's no processing to say, okay, we're going to put all the cookies together, right? What you'll get are the headers as they were received in the order they were received. Okay. Now, again, we may do some processing here later on this, but for right now, that's the way it works. Okay. Now, if you want to send headers and the protocol supports it, then you can do, I think it's called submit initial headers, and actually send a header object, right? Or submit trailers. It's either trailers or submit trailing headers or set informational headers, okay? Now, if the Quick protocol does not support headers, these will return false. So it returns a Boolean.
Does this API expose what type of protocol is going on top, or do you need to handle that?
You can. Everything is based on the ALPN identifier that is when the TLS handshake is being established. When the session is created, you specify the ALPN, which say if it's HP3. All the decisions under the covers are based on that. So when underneath the native layer, we actually have two what are called the HP3 or the Quick application. There's two of them. There's the default application and there's HP3 application, and we can introduce more. It's designed to be extensible. Once that ALPN is figured out, right, we select which application is actually going to drive the session, right? And it determines whether the headers are supported or not. The application does. So if you're using the default application, then none of the header events or the methods will be supported. You just won't get the events, and anytime you call any of the submit methods, they'll just return false right away. They'll be non-ops. Okay. If you're using HP3, then you will get the events, and these will, if you're in the right state, then the submit options will return true. Okay.
Right. Is there a property or a event that will tell us that it is a HTTP3 application?
Yeah, you can look at the LPN protocol.
Oh, okay, that's exposed on it. Okay. Yep.
And I'll tell you whether it's HTTP3. Okay. And later on, we might actually add some things about what features are enabled, right? Like a switch or headers enabled or not. Okay. But it's, with regards to this, there's no like send request or send reply. We're not differentiating client and server side here. It's the same events, the same submit APIs, whether you're on the client or server. So whether you're sending request headers or not, or listening or sending response headers, same methods. Okay. All right, so that is the basics on the client or on the server side. On the client side, now like listen, create socket, listen, and connect, they all have options objects that go along with it. They specify, which server you're connecting to, what TLS keys you're going to be using, and a variety, and there's a whole list of other configuration choices. I'm just leaving those out for now. So await quit socket connect. It's going to return a promise that is going to be a session object when it resolves. All right, now this is a client quick session. Like I said, there's some minor differences between the two, but for the most part, I'm going to ignore those for now. Here, the thing to keep in mind is when this promise resolves, you don't have to wait for like the session on secure events. You can if you want to, but if you immediately just start creating a stream here, okay, the promise that creates a stream is going to be resolved as soon as the client session is able to create the stream. So in this case, it's after the TLS handshake completes. That's when it is. So it kind of covers over the details, subtracts the details away of having to listen for that TLS handshake. And then you can just start writing stuff to that. It's just a duplex. All right, and you come in here, you can say await stream close, await session close. And you can even promise all these. So await. And in this particular case, you could actually eliminate that one entirely and just await session close. All right, so the difference with this await session close is if this is a bidirectional stream, this stream will not close until the server also closes it. Right? So that's something you got to keep in mind. In order to force it closed, you'd have to use destroy. Okay, this is only closing your end of it. Okay, now if you said that this is a unidirectional stream, you wouldn't read from it. As soon as you're done writing to it, it will close right away because there's nothing that you're waiting on the peer for. What's interesting about this is that you can open the unidirectional stream, write to it, end it, close it on your end before the server ever, before the peer ever actually receives any of the information. Okay. Any questions?
I assume the session also has an on-stream event, right? Because it is.
Yep, we can. Yep. So once you've created it, now because of the awaits and stuff, if you're going to be using the awaits, make sure you have your you attach your event listeners before you call any awaits. But yeah, you can do this. And this way, if this not the session on stream. So if the server initiates any streams, that's when you'll get the on-stream event on the client side. And it works exactly the same as the on-stream event on the server.
Do you happen to know, are there any browser implementations of this stuff for the client side yet?
So there is there's going to be a separate browser API for this. And that's something that I'm actually evaluating because I may end up actually implementing that. It's called Quick Transport. It's still very underdeveloped, but it's supposed to be able to give you a very simple, low-level, quick client, within the browser. Like I said, I'll probably end up implementing it. I don't think that it's going to be sufficient for a complete HTTP client. Right, we're still going to want to have a higher level HTTP client API. In typical browser fashion, they're hiding a lot from you.
Yeah, I see a lot of the benefit here being non-browser stuff anyway, so I'm not super concerned. I just thought it'd be, a nice thing at some point if there was a browser API, as we decide on where the client, how we want to build clients here, right? Because I brought up to Robert, at least in the Undici repo, like what does, do we want to build a client here? And I think especially if there's browser APIs, like we should skip the debate and just build the browser API.
Yeah.
So,
well, we've had a few requests to at least support quick transport once it's defined, once it's done. It's just going to take a little while before it can be done. And I kind of want to see what that looks like before I commit to it. Because if they end up saying, hey, it's got to use WG streams, right? We're kind of, we're kind of up our creek until we have all that implemented. So.
Yeah, that makes sense. Just going through this, it just seems like, this protocol would be great for a replacement for WebSockets as well. Like if you.
Without a question. Yeah, that's actually one of the key uses for this. What you're going to want to do, like I said earlier, in theory you could have HP3 and non-HP3 over the same quick session, but you're probably not going to want to. So with that,
do you have any details on why that wouldn't work well?
It's going to be because of the implementations. It makes the underlying implementation much more complicated. So, for example, with HP3, under the covers, when you start an HP3 session, it creates multiple unidirectional channels back and forth, multiple bidirectional channels back and forth. So a single HP3 session will start with with both the client and the server opening unidirectional control streams in each direction. That control stream is used for sending connection state back and forth. And then if you are using the header compression, each endpoint will both open two additional unidirectional streams in either direction. So just and that is used for the header compression decode and encode instructions. So just creating a single HP3 connection requires opening 6 unidirectional streams, 3 in each direction. And then you open an additional bidirectional stream for the request and the response, okay? Push streams from the server to the client, all of those are also unidirectional streams open from the server to the client. All of that assumes, is going to be assumed to be HP3 semantics. So there's specific information that's looked at on those. If your server and your client start opening their own unidirectional and bidirectional streams that do not follow HP3 semantics, then you have to have you have to implement an additional way of signaling, hey, this stream is not actually for a request response or a push stream or a control stream. And it just makes things much more complicated. So you can do it if you want to go do a hell of a lot of work, and it's probably not going to be interoperable. Creating a second session is actually pretty cheap. So if you want to do this, right, you would create your HP3 session, but then you could just create another session that has whatever protocol you want. So one of the things that I've been working on, I haven't been able to do much work on it lately, is essentially if you think like MQTT, it's a message queuing protocol directly based on Quick. Currently, I'm just calling it Quick MQ. It uses Quick's low-level mechanisms, very similar to MQTT, in how it's structured. But I can create one session, which is HP3, another session which is Quick MQ, and they're basically coordinating back and forth on passing data around. You're right; it can absolutely replace WebSockets. But we'd have to look at the more important thing is you have to look at what the actual application is, right? Are you just using raw Quick back and forth, or are there actual semantics like with HP3 that have to be implemented?
Yeah, that makes a lot of sense.
Yeah. That for the most part is it. Now the API, like I said, it's not finished. There's still a lot to do. It's hiding a ton of the details under the covers. If you look at the native code, it's massive. There's a lot there. So there's a lot of complexity that's been hidden away. There's some things that Quick API is going to offer that the other network APIs just simply don't. One example is statistics. There are all of the objects expose statistics properties. It'll tell you things like not only how many bytes were written and how many bytes were received, how many of each connection type, session type you received, how many packets were ignored, how many packets were successfully processed. We also produce histograms internally of packet sizes, delay times, the number of times packets had to be retransmitted. There's quite a bunch, and I'm going to be reviewing it to make sure that there's see what all is going to be useful. So it may have some changes. Some things may drop out. Some things may be added. But there are detailed statistics that are being collected, and the intent of that is not purely informational. The intent of that is to allow you to specify behavior if the server hits a particular load, if you're seeing bad behavior by a particular client or a particular IP address, you can respond more dynamically to that. So those features are going to be there. There's also a circuit breaker built in. Quick has an option where you can, it's got a status code, an error code, where you can say the server's busy right now. And that can be triggered from the Quick socket. So if you say, if you have your Quick socket, you can set server busy to true. And once that's true, any new attempts to create a new session will be rejected until that is flipped off. Okay. So aside from just the basic API, there's a number of elements in here that are intended to make it easier to respond to load more dynamically and more intelligently. Okay. The other thing that I've done is that so I added the block list support into Node in a separate PR. Eventually, that's going to make its way to the rest of the net functions, but you can specify on the quick socket a block list, which is a set of IP rules for endpoints that you're not permitted to talk to. So the block lists on the server side will reject client inbound requests from specified clients. On the client side, it will stop you from being able to open connections to anything in the block list.
Is there a corresponding allow?
No.
Okay.
Nope. It's just a block. So it's because Node has always been a we're going to allow everything by default, right? I'm not changing the default, right? So it's a specific block. So everything is okay unless it's in the list. Now you can specify very broad rules in here. So you can block, yeah, you can do it by IP address, you can do it by IP range, or you can do it by subnet. So you can come in here and say, I'm going to block, right? And give it a CIDR number, whatever. Whatever, I'm not sure what the number is, but, and it'll block the entire range. Let's add subnet. I can't remember the specific API, but yeah, it's going to give you quite a few options there for being able to block. Okay.
Do we have time to look at the HTTP3 layer?
So that essentially is the HTTP3 layer. It doesn't change much. So let's take a look at this. This is one of the tests that we have. All right, so we require a quick socket, and we're going to create the client. Create quick socket client, and here we also create the server. Notice, with the exception of some of the endpoint options, it's exactly the same. This K3 HP3 ALPN, that's just something we have in tests. That is basically the ALPN identifier for HP3, which in the end is just going to be H3. Right now it's H3 dash and then in the version of the spec we're implementing. So you have this options object. You specify your key cert, CA, and your ALPN. You create your client, your server with those options. All right, so here we're telling the client and server both to speak HP3. What you'll notice is there's nothing else in here which is specific to HP3 other than the headers. So if we look at the server on session, we get the on secure event, okay. We get the on stream event. So the on stream is the equivalent of your on request. You get the stream. We submit our initial response headers, right? We can pipe file data directly to the stream, right? That's our response. The stream on initial headers, here we are waiting for our request headers to come in. Notice the order that I did that in. It's when you get this on stream event, that stream event is going to be triggered when the stream is created. You set up all your event handlers, and then you start, and then you'll start getting the data from them. Okay, so you can put, set these things up in different orders. Yeah, if you want to get, we're not expecting informational trailing headers here. And then we, set up our stream listeners to get the data that is received. notice that other than calling the headers APIs and setting header events and setting the HP3 ALPN, there's nothing HP3 specific in this API. But this is implementing HP3. Okay. If we look at the client side of this, right here, this rec is your client side session. We're opening the connection to the server. We're awaiting the opening the stream. Once the stream is open, we submit our initial headers. We pipe our payload data. We're just ignoring whatever the server writes right here. Here, we wait for the response headers to come in, and we can start here. Actually, this stream should be taken out. But the stream on data, we get the chunk, and we deal with it from there. Again, other than calling these APIs for the headers, nothing HP3 specific, and even these aren't HP3 specific. I could implement a different ALPN protocol, a different application at the native layer that also supports these exact same header APIs.
What about push?
Yep, the push. Let's see. Push here. When we have, all right. So this is the one thing that is a little bit HP3 specific. The stream on the server side has this push stream method. If you have, in theory, we can have an API, a quick application that also supports push. That's not HP3 and would use the exact same API. So this isn't HP3 specific either, but it's modeled after HP3. All this does, push stream gives you a stream back. And then
that's not a quick stream now then. It's a HTTP stream.
Yeah, so this push stream gives you a quick stream object back, synchronously.
No, I mean the stream that you call push stream on, that's not on a quick stream.
That's
now.
a quick stream.
It does. Okay, so push stream is implemented on quick stream.
Yeah.
So that's part of which application is backing the session, right?
Right. So it's always there, whether it works or not, depends on which application you've selected.
And if it doesn't work, then it returns false, I guess.
Yeah.
That's very similar to what we were discussing, Wes.
Yeah, exactly. Yeah, that's kind of why I was interested in it. So this is also very similar to the HTTP2, API layer. Does that behave the same way? I'm trying to think with if you can't, it returns false.
So with HP2, push stream accepts a callback that is invoked if the stream can be created.
Yeah, that's what
in this case, it just returns synchronously because we can, right? We know immediately that it's we don't have to wait for anything. So it's going to return the push. If it's not supported, and if it's not supported, I think it actually gives you an error. I'll have to look at it. Like I said, the details on this may change. But if you get the stream back, right, then push is supported, and you can start using it. Now, if the client rejects the push, what will happen is that it'll just get closed. Right, that whatever stream you have. So you can start using it, you can start writing to it, but then you have to be prepared for it to close prematurely.
This is really cool. Wes, maybe we don't even need a HTTP 3 core layer. We just use Quick straight away.
Yeah, I mean, it looks really clean and straightforward. So you might be right. I do think the big work here, I think, is going to be having a single API that covers 1, 2, and 3. Yeah. I think the 2 and 3 will be like super straightforward. They're very similar. Seems pretty easy. The 1 stuff, once it's on top of Quick, but I still think no push streams. Like there's going to be some differences, and how I think we might be able to do the same behavior where it just, if you call it and it's actually an underlying HTTP 1 application, then basically it just is a no op and returns false. That might just work.
So the thing I'm mostly worried about here is like the push stream. James, you implemented it as synchronous, and in HTTP2 it has to be asynchronous.
Yeah. Yeah.
So is that maybe could you make it asynchronous?
Yeah, we can make this where this returns a promise, so you don't have to worry about whether it is synchronous or not. So there's a couple of things. HTTP1 over quick, it's not going to, we're never going to have a case where HTTP1 just always uses quick, right? But I've already tested it. Sending HTTP1 messages back and forth over quick works. And you can actually hack existing frameworks to, and it still just, and it works. It's kind of neat. But HTTP1 over TCP is always going to be the thing. HTTP2 over TCP is always going to be a thing. What I want to do for the low-level APIs is I want to take the socket session stream abstraction and use it for all of them. And this is part of the rework that we've talked about. For HTTP2,
these three would sit on top of either the UDP underlying layer or the TCP underlying layer.
Right.
Okay, cool. Yeah.
So right now with HTTP1, the socket and the session, are kind of jammed into one thing, right? And it's not very clear. It's not a clear separation. And in the new model, these would be separate things. So you would create the socket, and you would still have, whatever the socket is, you'd have an on-session event. Now with HTTP1 or HTTP2, that is basically the establishment of the connection, right? And so you'd have that on-session event, you'd get that session, and for the request, you would still say session on stream, okay? Now, for HTTP2 that supports multiplexing, right, then you can have multiple on-stream events happen concurrently, right, while they're still being processed. With HTTP1, the difference is that you'd only get one on-stream event at a time for each request you receive. And then, once you've got that, once you've processed through that, if they're using pipelining, right, you might get another one before it's completely, but you're only ever going to get one stream at a time, for your request and your response, right? Because HTTP1
while the readable side is open at a time, right? So the readable would, sorry, I got big noise coming.
No problem. Yes, they'd only be readable, writable one at a time, in the order that they're received. Okay. So there's going to be some differences there, but it's still going to be a session event with an on-stream, right? And then what you would do here for, if you want the higher level semantics, right? What you're doing is you would, if you want to treat this as a high level like request object, right? As a wrapper around the stream.
Right? Yeah, so one of our open questions is whether we want to move everything to a duplex API or decompose the duplex for HTTP 2 and 3 down to, the
right.
traditional rec res. I maybe have opinions, but they're not very strong yet, that I think the duplex API is more approachable. And the nice thing about when we, have this on top of Quick is that we don't have, if we pass the duplex API from the foundational layer all the way to the top layer, we don't have the performance hits of wrapping and unwrapping. We don't have like a few other things. And we also get just nice consistency. That said, it would be a big paradigm shift for end users to think about it as a duplex instead of a, two unidirectional streams as rec res. So
So exactly that. You know, so for HP1, what I'd like to get to, and it's going to take some time to get there. What I really want to get to is a point where it's the same. It's the same low-level interface for 1, 2, or 3, or any of the quick protocols. The details of whether it's TCP or UDP are abstracted by the socket, whatever the socket implementation is, and whether the socket can listen and be a client at the same time or not. That's all part of the abstraction of socket. Session is the abstraction for the actual conversation between peer and client, or server and client. Stream is the abstraction for the actual flow of data back and forth. We can map HP1 into this model. It's quite a bit different than the existing approach, but it does work. And the details, fall into the actual method. So submitting the headers, right? Whether a push is supported or not. But we can define those methods generically enough to where their behavior, their semantics apply. If the underlying protocol doesn't support it, you receive a false or get an error, right? Or if it does support it, then it just works.
I do, and I mentioned this to Wes, but I think me and Wes needs to have a longer discussion about it. I do see problems with using the duplex API, because as soon as you start, transforming the input and the output streams of the duplex, you end up having to unwrap and rewrap it from duplex to readable and then back to duplex, etc. That's basically what we ended up doing in Undici. And it has a quite significant performance hit. And it has to do a lot with how duplex is implemented in Node, I guess. But as it is right now, using a duplex, I mean, on the lowest level, I think it's fine because you can do the low-level implementation, so you're not wrapping and unwrapping. But when you go onwards from there, I do see a problem.
Okay.
I would really like to see some real world examples and maybe wrap those up in benchmarks so we can see and quantify this. So when we make a decision, we have the backing data to say, look, here's why we said, we're going to unwrap the underlying duplex stream and still expose rec-res, and look, here's our metrics. If we don't do this, it's, 25% worse performance across the board, and today I haven't seen that yet. Maybe you have some of that in your work from Undici, but.
I mean, I don't know I don't think Undici is very representative, but it's almost, it has almost a 50% performance hit.
Ooh.
So with wrapping it, it's 30,000 ops per sec, and without, oh no, it's not 50. Without, it's 40. So yeah, maybe 30% or something like that.
So I mean, one thing that I have yet to do are comprehensive benchmarks on this. Now, it's important to note that although the stream is a duplex, the readable and writable sides are completely independent of each other in this case. There's no interaction between them, and they can have completely different states. Like I said, it can be half open. You can close one side, the other side's still open. Et cetera. They do operate completely independently of each other. So you can treat you can wrap them separately as a readable or writable without impacting the other side. That's kind of what
I was wondering is if the APIs we expose just make sure that that's clear to the end user. Like if you need to transform the readable side, you need to make sure you. I mean, even that, you're not make sure you do what? Like you're just transforming the readable side. Like that seems not too super, problematic to me.
I think this is a problem on a higher level. Like if you're writing a middleware, and then you want the middleware to expose the same API as before it ran, then the middleware would have to rewrap it back into a stream again.
Yeah.
couldn't you just have a transform stream where the readable side transformed and the writable side was a pass through? And that's what you.
Yeah, but then you've separated them, and then you have to keep it separated through the whole chain.
Yeah.
Yeah, there are definitely some complexities here that at this low level, I can simply say, oh, I don't have to deal with that.
No, I mean, at this level, it doesn't matter. It's not really a relevant question. It's more, you know, the consumption of this API, how that would. So I'm sorry if this is off topic.
That's fine. I am going to have to get going now, and I know there's probably a lot more to discuss and a lot more things. So, you know, Wes, if you want to put together another call for next week, I'm happy to jump on and we can keep going through.
Yeah, I think let's at least wait for one more web server. I think that's maybe next week, Thursday, right? Is the next web server frameworks team meeting. So I think there is a bunch of high level, you know, design questions we have to answer here. I think your input would be great, but you are by all means not required. For that, we can continue now that the point of this was just to have a shared foundation of the understanding, you know, what these look like. Because I think we were making some assumptions, and I think most of my assumptions were probably borne out to be true, but at least now we know. And I think before we dig back into what does the in-between layer look like, I think we should have another couple discussions on what is the top layer, you know. Do we think the duplex stream is something we want to expose to end users? Where are the real tough edge cases there in exposing that? You know, how does it look like to have a server which supports TCP, HTTP1, and you know, quick HTTP3? Like those sort of higher level things, I think are going to dictate what questions we have for you, and what, you know, what we might want if there were changes we would ask for. And so I think we should maybe set another sync with you maybe 2 weeks out, so that we have a little bit of time to sort of process and think through those first.
Yeah, that's fine. You know, 2 weeks. You know, yeah, should be fine. Just give me about a week's notice. So I make sure I don't fill the calendar. I unfortunately I do have to run right now. But yeah.
Great work, James. This looks great.
Cool. I'm glad to like it. Any feedback. You know, pick it apart as much as possible. Things, if you're looking at things and they just like, you know, hey, we need this better. Like the push, whether it's async or not. Just jot those down. Let me know.
Yeah, awesome. Okay, yeah, we'll put together some notes and then reconvene. You know, in a couple of weeks. Like I said, we'll probably just plan that at the next Web Server Frameworks team meeting. So,
okay. All right,
sweet. Thank you so much. It was awesome.
Thank you. Bye.
And
Should
y'all
we
end the stream here? Since that's that, or do we have more things? I kind of have to go too pretty quick here.
Yeah, if you have to go, then cool. I was thinking maybe we could digest this, but we can do that in a.
Well, maybe we do. Want? I think I have probably at least 10 more minutes. Do we want to maybe spend the 10 minutes and see if, you know, while it's fresh in our minds?
Yeah, I mean, if we go back to, I would be interesting to how this affects, at least because we were on the GIS discussing the different layers of the whole thing.
Let me pull that up and then I'll screen share.
It would be interesting to revisit that now that we have a little bit more context.
I completely agree. So here, I'm gonna scroll down to your here. I'll share. Where's the share screen? Okay, you all can see the gist comments, right? Cool. So I don't know if you had all seen this. I posted the link before, but then we've had a bunch of discussion here, and it sort of, the only real difference that we arrived at is maybe we need another layer in between. But I guess based on this, I wonder, so the other layer in between was going to be this one, I believe. Am I correct?
Yep. Well, yeah, something like that. But basically now, the way I see it now, quick is the core layer here. So I would basically move it out and put it into the core layer. And then we basically have to implement the other ones in terms of the quick API James just showed us, no? You can edit my comment if you want, it's fine.
No. I always feel weird editing other people's comments. It's like, we'll just add new. So what we would do is we would move. So this is still, see, this is where the headers are sort of misleading. So what we, API we expose might end up being this.
I mean, I think it would even be quick itself. I mean, we don't have it the way James showed it. We don't really have HTTP3. It's just quick, right? And then we just have to create a wrapper for HTTP, HTTPS, and HTTP2 that implements that API.
And let's also change net to TCP because they're both in the net package.
You can remove low-level generic API there. It's basically quick all the way there, right?
Yeah, well, so that's sort of the question. So do we need a low-level interrupt layer between the TCP stuff? No, that's what James is saying, right? That will actually be abstracted away at the socket.
Yep.
And so, right, okay.
So the potential is that
that's basically quick compat, you know, a quick compat layer. Yeah, so we'll end up with something like that.
Just for,
yeah.
So there is a really, see, that's where I'd like having quick duplicated here. I'm not sure that makes sense to me. But like, these are the layers we would expose. So actually we can just like, so there is a distinct, oh no, there is a distinct layer below here.
I think it's fine writing quick there again. Yeah, exactly. Exactly.
Yeah, so this would abstract over quick and, or the quick API, not necessarily quick under the hood. It would just
exactly
be a quick compatible API.
Maybe you should write quick API there instead of just quick.
Yeah.
That API is what James was just showing us, right?
Yes, exactly.
So, to be sure that I understood what you mean, the idea is to have this quick-like API also for TCP sockets, right? In a way that the same code can handle both an HTTP 1.1 quick request as a transport and as well as HTTP 1.1 with a TCP transport, right?
Yes.
Okay.
And so presumably we would have some APIs. So what would the actual like exposed API look like here? So it would be, so one of the above, I sort of outlined something like this. Right. Does that seem, so this would be, actually it would be create quick server or something like that, right? Because we can't, because this would not create a TCP server.
Actually, would this work, Wes? Because, you know, this kind of API, and then you write listen on a specific port, but the different protocols would be working against a different port, right? You can't bind both UDP and TCP on the same port.
Well, right. That was my original question. When I think I tweeted this one at James and I was like, hey, but like, we can't upgrade from TCP to UDP without doing a full, you know, reconnect.
So I think we would end up with something like quick.create HTTP1 server, quick.create HTTP2 server. You would actually have 3 instances.
Well, not if it was, yeah, because he did say like you wouldn't want to do a WebSocket over the same as HTTP2. It's probably the same for an HTTP1 protocol, HTTP2 protocol, HTTP3 protocol, and the same thing, right? Yep.
I mean, this function could internally create 3 instances, but then the listen, you know, it doesn't make sense for the listen to take a port.
Yep.
Instead of writing true, false there, you could write allow HTTP and then the port number.
Or just a configuration.
Yeah.
Right.
Something like that, yeah.
So, but even this, we will have HTTP over QUIC and HTTP over TCP. HTTP 1, sorry, 1.1 over.
Yeah. I think it might be a good idea to start with, separating them and then try to find a unified, if it makes sense.
What if?
I agree that we should have 4 different separate APIs, and then let the high level, so the frameworks, figure out a nice API around it. So I think it's better to have a very clear and transparent API that clearly tells you what's happening, and then you can figure out a wrapper around it.
So if you had like framework, create server, and then this abstracted over creating 3 underlying servers, or whatever, however many you wanted, they frameworks API could.
Yeah, correct.
Yeah. Yep. And so this would call create server or something like that, right? Oops.
Yeah.
And then it would do the same thing. Oh, and then port.
Would we have QUIC plus HTTP1?
Ah, right. And then you'd have the same thing.
TLS or HTTPS, etc.
Yeah, it would actually, maybe what here instead we would just do an alias,
Yeah.
And that would be HTTP1 over HTTPS.
There will be 2.
HTTP2 then.
Well, right, but HTTP2 is distinctly always on top. Wow, see, so it's supposed to be, but we technically offer the API where it's not, right?
Yeah,
So
it doesn't work really well, but you are able to do an HTTP2 insecure.
It seems like we just shouldn't offer that. I don't know. I would have questioned that when that was being added, because
I mean, just to be, if we're looking at this from a practical perspective, I don't think we're going to do HTTP2.
Yeah, you brought that up in Indici. I'm still on the fence. Like completeness is obviously not a. If nobody's going to use it, we should definitely not spend the time. But it's so hard for me to think that we're just going to skip it.
No, I know.
It's like the same thing of like, we should like maybe like lay out the game plan of how to do it, at least think about it, and then say, hey, if you need this or want to do it, like come and contribute, because like we're not going to go here and gold plate for an API that's never going to be used.
No, I totally agree. We can absolutely discuss it. I just want to mention it early on, just so we're on the same page. I'm totally for it. If there's someone that really wants HTTP2 and wants to spend time, but just to set the, I think it's important that we communicate the expectations.
Yeah, I pretty much agree. And also, I would really like to see in the documentation, we only support odd version of the protocol. It will be very fun to see. Which is odd, you can agree, but.
So then just to be clear, what would happen here is
Did I lose everyone?
It's kind of cutting out for me at least, but it might just be me because I think I'm on.
I can hear Wes okay. I think Robert, I was having a hard time hearing you.
Yeah, me too.
So just to be clear, what would happen here would be, well, we do, on session, and then that would basically just map to, right? Does this make sense here? Sorry. Right, so like this frameworks would just map the fact that there's multiple underlying servers as if there was just one. So when a session came in on either server, it would then emit on the framework layer. Or actually what I think we would do here is this would actually be what we do on this layer, right? Because if all the frameworks are going to have to do it, I don't see a point in making everybody maintain an implementation of it. Did I lose people, or are we?
No, I'm still here, just trying to think about it.
Yeah, I'm still here as well and thinking.
So like if instead of this being the framework API, this was the, you know, whatever we call it. That's the name of the repo, I guess. It should be next.
So just to be clear, there will be a single HTTP package where you can specify if you want to have HTTP 1, 2, 3, HTTPS, and so on.
That is the proposal from what this sort of discussion has went toward. So that initially we were calling that the generic low-level API. And then there would be, and this would be the like supremely focused on performance, you know, so this would have like, this would have the 3 methods that we talked about, like, well, and maybe since we just outlined it down here, it's not 3 methods, it's just 1 method with different options or something. But like, you know, that's what this API would be in here. Then we would make a higher level API, which may make concessions on performance. Things like how James was saying, they don't even parse the headers, right? Like, so maybe the headers on the lower level API would be, you know, simple, and we would then enhance them here to be what most users might expect. And then the frameworks would have the choice of saying, do I want the low level headers or do I want the high level headers, right? So like a framework that didn't want to do anything special with them would just expose the same high level API that we build. But a framework that had some specific reason, or, you know, maybe there's a performance hit that we thought was acceptable here that they don't for some reason, they would just skip, you know, down to the underlying layer. Similar like what Robert laid out here with Undici, right? Is that like most people are like, you know, probably in here or here, but he offers the lower level dispatch API, which is used by all of these, that just does none of the magic stuff, right? So we would do the exact same thing here. Userland and everything below it is in core, but this is the one that we might expect somebody to actually import and use in an application. And this one is more, well, what James just demoed, right? It's like people probably aren't going to use it unless they're doing really specialized applications.
Wes, can you promote Robert?
Oh, he's sorry. Yeah, screen sharing does some weird. Hold on, I gotta find the. How do I get participants? There we go. I also have to drop here. I'm already a few minutes over. Do you want?
Yes, me too. This has been very, very useful. Thank you a lot. I guess we can definitely continue talking about this next Thursday when we have in any case, the meeting, and we can definitely start again from here.
Yeah, if someone could maybe add this video stream to onto the list, so people who are coming to that call know to maybe watch this video first or something.
Yeah, I'll once it finishes, I'm sure, because it usually takes a little bit for it to go from the stream to be you know, re-encoded. I'll watch for that and I'll make sure I post. Also, Robert mentioned, we've had a fairly long conversation here. It's in a gist, which is, you know, not necessarily in the repo. Would it be helpful for me to translate it over to an issue, link to it? Like, what do we want to do with the context that's all in here?
Summarize and put it maybe in an issue, or as a, summarize and put it as an issue, and then link to this original work so that if someone wants to read through the entire thing, they can.
Yeah, I guess we can probably for now keeping it as is. And then after next Thursday, when hopefully we'll have some more insights about this, we can start writing a summary but still also obviously keeping all the references.
Yeah, and one thing I would like for us to start, this is why I brought up doing GIFs, because they're nice and easy and quick and just kind of throwaway. But it would be nice once we get a little bit closer to what we all agree upon to have some example code in the repo, I think.
Yep, I agree.
Make pull requests against it as we evolve our thinking, you know, and have more concrete discussions like we have been having today, which I think is super valuable. So awesome. Well, thank you, everybody. So we'll follow up in the repo, and I'll see you all next week.
Cheers.
Bye. Thanks,
Have a good
everyone.
weekend.
Bye, thank you.